We're in 10.3 day 2, and I want you to start by trying this 150-point quiz. You should be able to answer these 3 questions. How can a quadratic equation have no solutions? If I have a coordinate plane here. It comes down to your understanding of what a solution is, really, huh? So let's go down to number 3 first. Let's correct number 3. Define the solution of a quadratic equation. Nico.
No x-intercept.
Oh, okay, you're answering number 1, kind of. Okay, so a solution. So the solution of a quadratic equation is.
X-intercept.
One answer is x-intercept. Give me another answer to number 3. Another definition for solutions. Meta.
Roots.
Roots. And the final one. Who knows the final one? Michaela. The zeros. I think you add an E when you do that. Okay, so back to number 1. Explain how a quadratic equation can have no x-intercepts, no roots, no zeros, no solutions. Nico.
No x-intercept.
Okay, so what does it look like on my little coordinate plane?
It is like to the right.
And so, okay, so this.
Yeah.
There we go, a parabola that does not touch because the vertex is above the x-axis and it opens up. And the other one would be opening down somewhere, and the vertex is below the x-axis. So there are no solutions because solutions are x-intercepts. That's not crossing the x-axis. Number 2, does that equation open up or down? It opens down, and you know that by the negative a, the negative part, right? The negative is a reflection in the x-axis. Okay, good. So, who got 150 points on that? Very good. Good for you. Today we're going to, I guess there is no E after zeros. Today we're going to focus in on finding the zeros of a function. During a test, if you're asked to find the zeros of a function, and then you raise your hand and say, well, Mrs. Smith, is that the x-intercepts? May I answer that during a test? No. You have to know that yes is the x-intercept. You know that. So if you in order to find the zeros of the function, what do you do? What could you do, Lauren? You could factor it. So yes, you're going to factor it. If you can, you're going to graph it, whatever. You're finding those things we just talked about. The solutions, the x-intercepts, the roots. Usually when they say find the zeros of the function, they will place the function in function notation form. What does function notation form look like? Casey? F of x. Usually that's the most generic one. So here you have it. Find the zeros of this function. Graph f of x equals x squared plus 7x plus 6. So the first thing a person has to know is that f of x, that left side there, could be replaced by what variable? Y. Okay? And then we can do what we've been doing all along. The reason they use function notation is because you may have more than one function that you're working with. It's a way to name them. So I could have function f and function g. When you're in Algebra 2, you're going to be blending functions together. You will literally place a function in your function. Isn't that cool? So in other words, instead of just putting a number x in, you could actually put an equation in for x. It reminds me of systems of linear equations where you're solving more than one, right? Imagine putting an actual function in for x. Like if I tell you if g of x was x plus 2. Now, wherever you see x's, you would substitute x plus 2 inside of there. That's Algebra 2. But we're not there yet. We're just getting used to function notation. So if you're going to find the zeros of the function, what do we do to set this equation up? We could write y equals x squared plus 7x plus 6. We could write that. But ultimately, if we're going to find the zeros, what do we do? Jimmy? We plug in 0 for what? For the f of x, which is the y, right? You just plug in 0. Oops, I've already factored it. So go ahead and plug in 0 and factor this equation. So we can say 0 equals x squared plus 7x plus 6, right? And so now when you factor that, what factors of 6 give you 7 in the middle? 8? So we could say x plus 6 and x plus 1. So what are those x-intercepts? Good, -6 and -1. That's what would make those 0. And so we know those are the x-intercepts. So what can we do with that? We can graph those, right? So make sure you show your scale. We have an x-intercept at -6 and -1. What else do we need in order to graph this parabola? The most important other thing that we need. Juliana? The axis of symmetry and also the point that goes on that, which is called the vertex, right? So how do we find the axis of symmetry? Everybody say it, ready? X equals? Okay, everybody together. X equals -b over 2a. And then we'll plug that in and get our y value. So we go back to the original standard form, right? And what is the b, Izzy? So the b is actually 7, right? And so we put the negative in front of the b, -7. And then what is our a? 2 times 1 is 2. So we have -7 over 2, or negative, if we change that to a decimal, that'd be -3.5, right? And so now we're going to find the vertex. -3.5 is our x. How do we find the other coordinate for the vertex? Jimmy? Good, so we're going to use the original equation, but instead of 0, we're going to call the f of x y, right? Y will equal -3.5 squared plus 7 times -3.5. And then the last was 6, plus 6. And does anybody have that? What is -3.5 squared? Okay, positive 12.25. And then we have negative what here? 7 times -3.5 would be -21, and then another, how many negatives? What is 7 times a half? 3.5. So Anderson, what do you think it is? Good, -24.5. Anyone get that? Anyone else get that? That sounds reasonable to me. Okay, and so what would 12.25 minus 24.5 be? Isn't 12.25 half of 24.5? Yeah. It is, isn't it? So it equals what? Negative 12.25, and now we simply add 6 and we get -6.25. There's your y value, -6.25. Okay, so we can walk -3.5. We can actually draw in our axis of symmetry there. And then we can go down 2, 4, 5, 6.25, 6 1/4. Be as precise as you can on the paper, 6 1/4. Do we know any other point on this parabola, Juliana?
Yeah, 6.
What is that?
5%.
This C is your y-intercept. Good. So we could go up 6, 1, 2, 3, 4, 5, 6, and plot the y-intercept. Y-intercept equals 6. And then how far from the axis of symmetry is the y-intercept when you look there? How far is this point from the axis? How far?
2.
Well, look at it. Our axis of symmetry is where? -3.5, right? -3.5. So we go half and 1, 2, 3 more, and we are at a reflected point, right? The y-intercept can be reflected across that axis of symmetry. And if you want, you could then place those and be more precise when drawing your curve. Okay, there you go. Okay, so here's the most challenging, using graphing to approximate your roots or your zeros or your solutions or your x-intercepts, whatever you want to call them, right? Using graphing to approximate to the nearest 10, that means that these x-intercepts are not what?
Rational.
Well, they are rational, but they're not at exact integer locations. So like we saw here, our x-intercepts were at -6 and -1, beautiful integers, right, where the blue lines intersect on a piece of graph paper. Not all parabolas are that beautifully intersecting. Sometimes the x-intercepts are between a couple numbers. So how does one do this without advanced methods of solving, which you will learn? You would graph, okay? So you're not going to do this a lot, but you're going to do this today. You're going to graph to approximate the zeros of this function. And so, why? Because you want to be able to problem solve in many ways, right? And it gives you an understanding of what you're finding. Because as often as we say, what are the solutions of a quadratic equation? See, you're not as loud as you were last week, are you? What are the solutions of the quadratic equation? They are? The x-intercepts. Still, people forget that that's true. So graphing helps you to really conceptualize the fact that these are two places, often two places on a graph. Okay, so how do we do this? I've hidden the method. First, what would you do? What do you think? You get this function, you're supposed to approximate the zeros. What would you do, Nick? Okay, so what would you do with this f of x side?
Just
Make it 0, just like we just did. Let's make it 0. 0 equals x squared plus 2x minus 4. So yes, the first thing that a student will try is factoring, Nick says, right? And so, is the last term a perfect square? Is a negative number a perfect square?
No.
That's the problem with it. It's not a perfect square. Okay? So can you factor it the normal way? X. It's a -4 on the end. What does that mean for our signs? Positive and negative. Are there factors of 4 that subtract out to be 2? Give me the 2. What are they? 2 and 2 subtract to be 2? 4 and 1 subtract to be 2? Are there factors that subtract to be 2? Oh, what do we call this? Wait a minute. No, we don't call this no solution. We call this unfactorable. Can you say that? Okay, so we can't factor. Not factorable. So how can I graph? How can I graph? Wait, can't we use some other stuff we've learned? How about, can we find the axis of symmetry? Let's go see. X equals negative b over 2a. So negative, what is b? 2. And what is a? What is a? Look up here. So 2 times 1 is 2. So the axis of symmetry is where? Negative 2 over 2 is negative 1. So we do have a location. Okay, so we have that. So what can we now find since we have that axis of symmetry? What can we find? Well, what does that mean? Vertex. Good. Find your vertex. Yes, the x value of the vertex is at negative 1. So we're going to use this equation. Y will equal this equation, right? Negative 1 squared plus 2 times negative 1 minus 4. And negative 1 squared is 1. And 1 plus what is 2 times negative 1? Negative 2. And we have negative 4 as well. And when you add these three numbers, Braden, what do you get?
-5.
-5, yay. We have an actual vertex at -1, -5. -1, -1, 2, 3, 4, 5. What else do we know about this parabola? Chat.
The y-intercept is -1.
Yay, y-intercept is at -4, right here. -4. And how far is the y-intercept from the axis of symmetry? Only one away, so we go one this way. Okay, so now, is there anything else we can do to, using the equation right now, looking at that, is there anything else jumping out at you? No. So what can you do to try to locate stuff over here? What could you do? Huh? You could try to draw a parabola, but I don't have a true sense of how wide it is. It looks like it's kind of narrow based on these 3 points, right? So we could make a table, and that is what we need to do. So in order to keep this parabola in sight, you are not erasing on your page, but I'm going to erase here. So you can see the table next to this graph, okay? So do not erase at your page. I'm just giving us room for the table. You will be using a table again today. And where was that critical vertex? We just said it was at -1, -5. Okay, so there it is. Now, where I guess we could try to draw, let's try to draw. I don't know where to go here. I don't know, maybe here. Something like that. I'm just trying to get an estimate, right? So where does it kind of look like based on what I'm drawing here? It looks like this left x-intercept is crossing between -2 and -3, kind of, doesn't it? Between -2 and -3. So, give me some number just a little bit where you think it might be crossing between -2 and -3. To the 10th place. What do you think? Is it closer to -2 or -3? -3? And so how about -2.8? So that's what we're going to try. We're going to plug in -2.8 to get the y value. And see how close the y value is to what? What do we want the y value to be? What do all x-intercepts have as y values? 0. You want your y value to be as close as possible to 0. Okay? So when you plug this in, who has done it already? Quick, to save us time, use your calculator. What is -2.8 squared? This would be -5.6, right? -2.8 squared must be positive. 7.84? We got -1.76. That doesn't feel very close to 0, does it? Where will you go? Who wants to go further negative with your x? Who wants to go further a little positive with your x? More people are saying positive. So give me the next thing that we could try. Carly. -2.6, it's a little more positive. Okay, so I feel like I need to move this term over here. Hey, it moved. -1.76 there. Let me get it over there. Of course, this board is going to move it all separate now. -1.76. -2.6. Have you tried it, Carly? Did you put it in every single location here? Or are you just telling me the first? Okay, so when you stick it in like that and you do all of the calculations, what do you get? Did we get closer to 0 now? -2.44. Did we just get closer to 0? No. Okay, so now where do we want to go? More negative. How about what? Give me something. What do you think? We moved 2/10 closer to the vertex, closer to the axis, and we got almost a whole unit further down. So, what did I hear? Negative, who wants to try -3? That's an easy number to try. Let's try that. -3. So when you plug in -3, -3 squared is 9. And then 2 times -3 is -6. So 9 minus 6 is 3. And then 3 minus 4 is -1. Are we at 0 yet? So we're going to have to go further to the left. So do you see how I did not have enough points really to do a nice parabola there. I don't know if some of your parabolas look different on your own paper if you have graph paper, but it looks like this parabola is somewhere between 3 and 4, doesn't it? So we have to keep testing. Okay, so let's go. And this is what you do by hand. I know it's tedious, and you don't want to do it. But, oh well, we do. Give me the next estimate. Negative what, Jimmy? -3. Okay, we're getting closer. We're at 0.29. So the question is, do we go a little further negative? We want to get to as close to 0 as possible. So, Ryan? As close to 0 as possible. I don't know if 0 will be exactly found to the tenths. It might be exactly found to the hundredths, you know what I'm saying? But they ask us to go to the tenths most often, so that's what we're doing. So where could we go next? How about -3.4? Has anybody done that already? This is 3.4. What is it, Lauren?
0.76.
Say it again.
0.76.
Ooh, 0. Was this other one negative, this 2.29? No? It was positive? So 0.76. Do you see how we're getting a little bit above? Right? This one here is a little bit above 0. And now we're getting further above 0. Right? So this one is feeling really the closest right now to 0. What could we test just to confirm this? This was -3.3. So what could we test? Harley?
I did -3.2 and I got
-3.2. I'm changing this one to what she did. -3.2. And she got negative what? What's closer here? I'm going to erase this and try to make it cleaner. -0.16. What's closer here? 0.29 or -0.16? -0.16. Did you try any others? What would be another one you could try right now? Carly? Well, we're supposed to go to the tenths. So rather than -3.25, what's the next tenth down? -3.1. Has anybody tried that? Let's see that one. What is that? -3.1. Okay, so -3.1 gives us -0.59. What's closer to 0 here? We know this one's not, right? Out of these three, which one's closest to 0? -0.16. So this seems to be the best route to the tenths, the best solution to the tenths. We have one solution at x equals -3.2. Now, how can we use that to find the other one? We know that this crosses at -3.2. How can we use that known information to find the other one over on the right, rather than going through this horrible calculation that we're going through? Come on, what about this parabola graph can help us right away find it? Riley? The axis. How far away from the axis of symmetry is -3.2? Where was the axis of symmetry? Where was it? At -1, right? -1. So how far away from -1 is -3.2? 2.2, right? 2.2 that way. So we want to go 2.2 this way to find our other intercept. And what is negative 1 plus 2.2? It's, say it, Anderson? 1.2. X value of 1.2. So we go immediately to 1.2 and test it. What does 1.2 give us in the equation? And yes, we've got the other closest solution to the tenths. It's 1.2, the same distance away from the axis of symmetry. Okay, so to put it in a little method note, right? The first thing we do is graph it, and then we start estimating to the tenths where we think it's crossing the x-axis. And we start testing it in a table. Horribly, horribly tedious. Looking for which point comes closest to the y value of 0. And the points we found that were closest to a y value of 0 were these two. Okay? And that is what you're going to try to do today. You do not need to write this down, but there may be a question today that involves something that we've worked with before. Tell me, don't say it yet, but a baseball player throws a ball at an initial velocity of 32 feet per second. The ball is released at a height of 5 feet off the ground. Could you write the model for that scenario in a math equation? Right now, raise your hand, tell me who can give me this in a math equation. All of you should be able to. If you can't, then you are behind. And if you can, say it with me. Ready? 3, 2, 1. H equals negative 16t squared plus 32t, good job, plus 5. Good. It is your projected object model. So you may need to look at that today, too. There you go.